Good morning, good afternoon, and good evening. This is Mr. Payne bringing you Unit 1, Lesson 5, Equivalent Expressions. The idea of equivalent expressions or equivalency is extremely important. It is the basis of many, if not most, of our algebraic manipulations. Equivalent expressions. Two or more algebraic expressions are equivalent if they have the same value for every value of the substitution variable or variables. In other words, no matter what value you stick in for x, the two expressions come out equal. Let's look at that exercise. Exercise number 1. Consider the three expressions below. By substituting in the values of the given x given, determine which two expressions are equivalent. Show your calculations of the expressions, values, and circle your final answers. So the very first thing that we're going to do is x equals 7. So we're going to take that 7, we're going to plug it into each value for x. So the first problem says 5 times 7 minus 3. Well, we're going to do 7 minus 3 first, which is going to give me 4, so I'm going to do 5 times 4, which gives me 20. The second expression is 5 times 7 minus 3. 5 times 7 gives me 35. Minus 3 gives me 32. And the last expression is 5 times 7 minus 15. 5 times 7 is 35. Minus 15 gives me 20. I want you to notice that these two expressions are equal. I want you to start thinking about, we're going to hold off on x equals 0 and x equals 1 in your notes. We're going to talk about those in class first thing. But I want you to start to notice why you think those are equivalent. Take a look at the two expressions that are up at the top and see if you notice anything, and see if you can figure out why those two expressions are equivalent. I'd like you to jump down now to exercise number 3. It says, which of the following expressions is equivalent to 5 times 2x plus 1 minus 4? Show your work to justify your response. Test at least one value of x to check your answer. So I separated my screen into my work screen and my check screen. The first thing I'm going to do is write down the problem. 5 times 2x plus 1 minus 4. So the first thing I need to do that I learned in lesson 4 is distribute. Take the 5 and multiply it to the 2x, which gives me 10x, plus 5 times 1 is 5, minus 4. Using PEMDAS, we're going to continue to simplify this expression. 10x plus 1. Noticing that choice 3 is the correct answer. Now, we're not done with our work and getting full credit on this problem. It does ask us that to check with at least one value. So I'm going to pick the value of 2. I'm going to say, all right, x equals 2. So if I take x equals 2 and I plug it into the original equation, 5 times 2 times 2 plus 1 minus 4. So I'm going to get 5 times 2 times 2 is going to give me 4 plus 1, which is going to give me 5 minus 4. 5 times 5 is 25, minus 4 is 21. Then I'm going to type it into the new equation, or place this x equals 2 into my new equation. 10 times 2 plus 1. That's going to also equal 21. That proves that this expression and this expression are equivalent. Let's hop now to exercise number 5. We're going to save exercise 4 for class. So exercise number 5. Which of the following expressions is equivalent to 10x plus 15? Explain how you made your choice in the space provided. So I'm going to give you a minute to think about this. Well, if you chose 2, you would be correct. You can think of this in 2 different ways. If you remember factoring from 8th grade, you can do simple factoring. If not, you can go down to your answers and just distribute every one of these. So number 1, if I were to distribute the 2, I would get 16x plus 26. That is not equivalent to 10x plus 15. If I went to number 2 then, and I said, all right, 5 times 2x gives me 10x, plus 5 times 3 gives me 15. That's the correct answer. So this expression is equivalent to this expression, written just 2 different ways. I just mentioned in the last problem about factoring expressions. Factoring is the process of writing an equivalent expression as purely the product of other expressions. Remembering what product means. Product means just 2 things that are going to be multiplied. Factoring will be one of the most important skills that we want to reach fluency with. But for now, we will do some fairly easy factoring by simply applying the distributive property in reverse, if you will. Exercise number 6. Factor each of the following expressions by writing an equivalent expression. That is the form of product. There it is again, product. So I'm going to show you what that looks like. Check your work by using the distributive property. A, 6x plus 21. Okay, well, I want to think about what number goes into both 6 and 21. If you said 3, you are correct. That is my greatest common factor between 6 and 21. So I'm going to say, all right, I'm going to divide each by 3. When I divide each by 3, I'm going to pull that 3 and I'm going to put it out in front of my parenthesis. Six divided by 3 is going to give me 2. X just comes down because we didn't divide by anything. Plus 21 divided by 3 is 7. This is a product of our other expressions. Do you see how I have 3 times 2x plus 7? That is a product. So if I would say 3 times 2x plus 7, the product of that would be 6x plus 21. Now let's take a look at example B. The greatest common factor between 2x and 10 is going to be 2. Ignore that minus sign out in front for the time being. So we're going to divide by 2. We're going to divide by 2. When I divide by that same number, I can pull that out in front. We call that our greatest common factor. Now that negative comes out front here because we just bring that down. 2 divided by 2 is 1x. Plus 10 divided by 2 is 5. I would like you to complete C on your own and have that ready for us in class. All notes should be filled in, and you should now write your WSQ. Please don't just sit and watch the video. Make sure you filled in your notes along with the video.